Hi guys. Today we'll be continuing with the unit standard 12 1 2 triple four. The title is Measure, Estimate and Calculate Physical Quantities and Explore, Describe and Represent Geometrical Relationship in two dimension in different life or workplace contents. So what will be going through, what I'll be going through with you, it's just the properties of how to measure and so forth. So we'll just go down the properties and how to calculate some of these properties to use mathematical uh, uh, functions within these properties. So the first one is measurement. So measurement is how we determine the exact capacity of something that is in solid, liquid or gas form. So you also have measuring instruments. So for each type of measurement, there is a particular measuring instrument which is most suitable to do the job. It will be impossible to list all the possible measuring instruments. Thus, we'll look at the most common instruments. First, we have a ruler. We are familiarized with what is a ruler is. A ruler that is in good condition is a practical instrument for measuring shorter, straighter lines. We can measure millimeters and centimeters with a ruler. We know the functions of a ruler. In opposite directions, on the end side we've got centimeters, on the other side we've got millimeters. So these measuring instruments, one of it is a ruler, and also what we have. So the second measuring instrument is a vernier caliper. So a vernier caliper is used to make semi-accurate measurements for out and inside, outside, and depth dimensions. So a standard vernier calipers are available in sizes of 150 millimeters to 250 millimeters. So it's more of a custom made vernier calipers can be made to specific specification if required. So this is how a vernier caliper is. So I've extracted this figure from your learner guide. So you just have to know the properties of a vernier caliper and in terms of the sizes that it has. So the sizes that it has which are available, it's from 150 millimeters to 250 millimeters. Moving right along, on the next slide we have measuring tapes. So a measuring tape is used when a ruler is too short to measure the distance or length. Some of you are familiarized or have been exposed on to a measuring tape. Builders mostly, people who are in a building world, they use more often a measuring tape. So they use the measuring tape to measure the short distances in meters. So measuring tape are usually graded in millimeters, centimeters and meters. Also, we've got thermometers. Temperature is measured using a thermometer. A thermometer is often filled with mercury, and the higher the temperature rises, the more the mercury expands and shows the temperature reading. Also, we've got scales. When we need to find the mass of an item, then we use a spring scale or a kitchen scale. We measure in grams or kilometers how heavy something is. So these are just tools that we use. And also we've got watches and clocks. We can measure time on either an analog or a digital clock. An analog clock is marked in 12-hour intervals, and the clock hands need to pass the 12 for the second time to indicate a 24-hour period. And also we have an SI and imperial measurements. So an SI is just a standard international unit system, is based on the metric system, which means that we use 10 as the base number to increment various measures. So what I will do, I'll just provide an example with regards to how can we convert from meter to decimeter, or from meter to centimeter, or from meter to millimeters, and vice versa. Okay, let's say for instance, let's get the properties right. um, let's say we want to change from meter to centimeter. We know that the formula for it, we need to times by 100. We need to times that by 100 in order for us to move from meter to centimeter. Vice versa, we need to divide by 100. So if you want to convert from centimeter to a meter, we need to divide by 100. And also, let's say for instance, based on what we were given, we want to convert from meter to decimeter. We need to convert, or we need to times that by a 10. Vice versa, from decimeter to meter, we need to divide that by 10. So we want to move or convert from decimeter to millimeter. Let's confirm that. Yes, millimeter. We need to times that by 1,000. We need to times that by 1,000. And when we want to, this is millimeter. Let's say you wanna convert vice versa, convert from millimeter to decimeter. We need to divide that by 1,000. So the standard formula for that, let's take for instance, for 1 meter. 1 meter is equals to 100 centimeter. So let's say for instance we were given 5 meter, and we were required that we should convert that into centimeter. So the standard formula for that will be you'll have to divide 5 centimeter by 1, and times that we need to times that by what we were given here. So this is the standard mathematical tool that we can use. So in this instance, we need to include 100 at the top, centimeter. Okay, this is C divided by 1. Our answer, it will be 5 times 100. That will give us 500 centimeter. Let's say we were given to convert from 500 from centimeter to meters. What we need to do, sorry, this is a meter, it's not a centimeter, this is a meter. So we were given to convert from 500 we're given 500 centimeter. We need to convert that to meters. What we need to do, we will what we will do, we'll put 500, divide that by 1, divide by 1 times 100. one will cancel each other. When you divide 500 by 100, that will give you 5 meter. So that's how you convert from meters to centimeter. Let's say let's do another example. We're given 0.9 meters. Meters, and so this meters, and we are supposed to convert that into let's do this. Let's start with we're given 29 centimeters, and we have to convert that to meters. So what we'll do, we'll take 29, we'll divide it by 1, divide that by 1 meters all over 100. That will give us 29 over 100. Our answer will be 0.29. And when we want to convert that to meters, we'll have to times that by 100, and that will give us 29. So this is just a basic formula in terms of how to convert from meters to decimeter, decimeter to centimeters, from centimeters to millimeters. What you need to understand in this basic formula in mathematics, when you go to the right, you times everything. So from meters, when you want to move from from meters to decimeters, you have to times that by 10. If you want to move from 1 meter to centimeters, you have to times that by 100. From 1 meter to millimeters, you need to times that by 1,000. If you want to do the opposite, do the inverse of it, if I may put it that way, you'll have to divide everything by 1,000. From millimeters to meters, you need to divide that by 1,000. So let's say, for instance, you want to move from decimeters to centimeters, you times that by 100, and from decimeters to millimeters, you times that by 100. Well, in this instance, since we used this, it will change because of now we're dealing with decimeters. It will be 10 decimeter equals to 100. So when we move to decimeter to 1,000, we know that that's millimeters. We going this way, we times, going that way, we divide. So we want to move from centimeter to millimeter, we times. Going this way, we divide. So this is the basic formula in terms of how you can go about in terms of finding when you are given situation to calculate. So moving on to the next slide, we've got the length. So length is the distance between 2 points. Like for instance, we've got length, we've got A and point B. So the symbol for length is it's m in meters, and you'll be required to calculate or find the distance between this point and this point. So this is how you go about in terms of The properties for length. And mass also is just a measurement for the quantity of substance present in a body. So mass is different from weight. Weight is just a measure of attraction of the earth for a given mass and is measured in newton. So also you've got the temperature. So temperature is the condition or degree of warmness or coldness of a body. In South Africa, we use degrees Celsius, and in some other countries, Fahrenheit is the standard measure for temperature. If you need to convert from Celsius to Fahrenheit, then we use the following formula. So this is just the formula for Fahrenheit. C represents the Celsius that you are given, and this is just a formula. So let's say for instance you were given 30 in South Africa. Let's say for instance in Gauteng the temperature is about 40 degrees, and you need to convert that into Fahrenheit. So we'll use that. Let's do this. I don't have space. Okay, I still have space. You are given 40 degrees. This is in Gauteng. This is in Gauteng, and you need to convert this. And let's say maybe you've got a cousin in Egypt. In Egypt they use Fahrenheit. So you've got a cousin in Egypt, and you just wanna explain to your cousin that the temperature, it's too hot in Gauteng, and you wanna tell him the exact temperature in Fahrenheit. So we'll use the formula in Fahrenheit in order for us to convert. So we've got 40. So let's convert. It will be 40 times 9 over 5 plus 5 plus 32. So in Fahrenheit, it will be 104 Fahrenheit. So we call, yeah, our abbreviation will be in Fahrenheit. Our symbol, this is in degrees. So when you explain this to your cousin, you inform him or her that the temperature is 104 Fahrenheit. So this is equivalent to 40 degrees Celsius in Gauteng. Let's say you want to do vice versa. Your cousin informs you that in Egypt the temperature is about 150 Fahrenheit, and he wants to uh, convert that into Celsius so that he can be able to say the relevant degrees in Celsius. So we'll use the formula. The formula is 5 in Fahrenheit. It is 150 minus 32 times 9. Okay, let's do this. Okay, so what we need to do in this instance, we have in brackets we have 5 Fahrenheit, we have 150 150 minus 32 close brackets degrees. This will give us 5. This will give us 5, and this is 118. We're not timesing this. We're not timesing this and this, so we'll have to times this and that. It will give us 590 590 And in this instance, what we need to do, we need to divide everything by 9. 9 will cancel 9, then you're left with Celsius, and your answer will be 65. It was 65.5. So when you round that into the nearest digit, it will be 66 Celsius. So your cousin in Egypt will tell you that the temperature in converting 150 Fahrenheit into degrees Celsius, it's 66. Yeah, it's so hot. So that's how you convert from Fahrenheit to degrees Celsius, or degrees Celsius to Fahrenheit. So let's move on to the next slide. We've got an area. An area is just the size that a plane surface or two-dimensional shape take up between its boundary lines, which means it's your length and breadth. So area is calculating by multiplying the length with the breadth. So areas in normal cases is multiplied by your length times your breadth. That's how you can get your area. So it's mostly covered the area of a rectangle, of a perimeter. It's this shaded part, that's your area. So we are looking for that. In most cases, this image I've extracted from your learner guide. It explains more. The block in the figure below shows much space this figure takes up, and this is called the area of the figure. So this space that is covered is mostly the area of the rectangle. The answer will always be followed by the measure squared. So the answer that you get in terms of calculating your area will be always in meters per squared. Okay, let's move on to the next slide. Volume is the amount of solid mass that a solid three-dimension figure occupies. So we've got your length, breadth, height, and or depth. So volume is calculated by multiplying length by breadth by height. So the volume in most cases, its formula, it's mostly being multiplied when you multiply uh, your length times breadth times height or depth. So this is just a formula for volume. So a velocity is the rate of motion or speed that something travels at in a particular direction. So I have an example for that. So I want to provide an example, but first what we need to do, just have to okay. So for velocity, for example, we've got a formula for that in order for us to, so we've got your d for distance and s for speed and t for time. So this is how to calculate velocity. So we've got three components. So if you want the distance, your distance will be speed times time, and your speed will be distance divided by t, which is time, and your time will be distance divided by speed. So this is the easier way to get your answer in terms of what it is required. You would be required to determine the distance or the speed or the time. So these are just your your formulas in which you can use in terms of velocity, the rate of motion or speed. So it's easier like this when you attempt your questions on your formative and summative assessment. Use these formulas, you won't go wrong. You won't go wrong. Moving on, we've got the acceleration is the rate at which velocity of an object is increased per unit of time. So the unit will be in meters squared. It's just in simple basic terms an increased of the rate of at which velocity of an object is increased. So this is very important. Just have to know these properties, that's all. So we'll move on to the properties of geometric shapes. So we'll just refer to the learner guide page 84. So page 84, it's under session 2, exploring transformations of two-dimension geometric figures. The properties of geometric shapes. So these are just properties that you need to know. So each geometric shape has its own characteristics by which you can identify and recognize. So geometry is the study of how lines interact with each other to form angles and shapes. Also, you've got triangles. Triangles, when lines meet each other, they create shapes. A shape made by three lines is called a triangle. Angles of a triangle always add up to 180. We've got types of triangles. We've got the scalene triangle. A scalene triangle is a triangle of which each of the three sides is of different lengths. In other words, A, B, A, B is not equals to BC. You can even see on the figure that is being displayed is that AB, their angles, their lines are not equal to each other. And also BC, BC is not equals to AC. BC is not equals to AC. So this is just a property in which you should know of a scalene triangle. So we've got an isosceles triangle. So an isosceles triangle is any triangle of which two sides are equal in length and two interior angles are equal size is called an isosceles triangle. As you can see, A and B are equal, A, B, and C are equal, and angle B and angle C are equal. So an equilateral triangle is a triangle of which all three sides are equal of length and all angles are equal size. So this is an equilateral triangle. So each angle are equal and their angle is 60. Many times it has to give in an equilateral triangle, all angles should made up of one should give you 180. When you times all the angles, all the 60 angles, it should give you 180. So we've got a right angle. In a right angle triangle, one side of the angle is 180. Let me show you that. And a right angle is something like this. This side is 90. This side is 90. So this is a right diagonal triangle. The longest side in the right angle is called the hypotenuse. So this is the hypotenuse. This is the hypotenuse, and this is an adjacent. Is an adjacent, and the other side is. I'll just remember now. Okay, I'll just remember now. Where is the right triangle? Oh no, man. Let's look into what's that right triangle. I just wanna and right triangles go alongside of these. Oh, I think it's your R. I think it's your R. We normally use that when we want an angle. For example, let's say uh, we were given uh, it's R squared equals to x squared plus y squared. So let's say, for instance, we were given two sides and we are looking for the side. Let's say this side and hypotenuse, it's we're given 9 centimeters, and in an adjacent side we were given 20, and we were told to find out this side. So what we can do, using this formula, this basic mathematical formula for the Pythagoras, what we'll do, we'll on the x represent adjacent, and y, yes, this is y, this is y, and this should be r, yes. So your x, it will be 20, it will be 20 squared plus y. That's what we don't have. And we were told to, let's rephrase our question. We are told to find y instead of r. We do have our r, which is 9, times that. So 20 to the power 2, it's 400. 9 to the power 9 to the, I think it's 81. Yes, it's 81. It's 81 equals to 400. 400 plus y squared, and when you take 400 to the left hand side, it will change its sign. So in this side it's positive. When you change it to to this side, it will be negative. So minus 400 plus 81, we have minus 300. We know that the answer will be minus 3. Okay, minus 319 equals to y squared. So in order for us to remove the squared, we need to use a square root. So because of we've got two answers, plus or minus, one answer will be undefined, which is the minus one. The minus of a square root will give you an undefined. We'll look on to the positive one, which is 3, the square root of 318, 319, sorry. Uh, it's 319 y is equals to 17 plus or minus. It's not even minus, it's plus. Yes, it should be plus, because minus it will give you undefined. Anything minus 10 on 19. Yes, it will give you 17.86. So this side will be, the y side will be 17.86. So that's how you find, in terms of using the Pythagoras, your right angle triangle sides. So in most cases we use that formula in order for us to find angles that we were given. So there are a lot in terms of the type of your rectangles, so you can just go through this on your own and know the properties of these angles. There's quite a lot, so I'll just look into the circle. A circle is formed when a continuous line, your circumference starts at 0 and it ends at 360, similar like your pi. So the center is your radius, your center, and you've got the circumference. So these are just the properties of angles that you find. So you just have to go through this on your own. It's not much complicated. The good thing is that there are formulas within these, and we'll go through that. It's not complicated, but you just have to go through the properties on your own, and when you go through the formulas, it will make much more sense, like your Pythagorean theorem. It's in a right angle triangle, the square of the hypotenuse, the longest side opposite is equal to the sum of squares of the two sides. Okay, this we went through, so this is not a problem. It's not a problem. So we've done this, we've done an example that's similar to this. We have done that. We could think that's it when it comes to session 2. So let's move on to session 3, which is exploring transformations of two-dimensional geometric figures, estimating, measuring, and calculating. We know that when we want to calculate our length and breadth based on our formula, what we need to do, it's more of an area. So if we were given, let's do this. Let's do this. Okay, let's say for instance we are given 7 centimeter and 3 centimeter for argument's sake, and we are required to calculate the area of this rectangle. What we need to do, we need to use the formula length times breadth. Your length is 7 meter times 3 centimeter. What we need to know is that these sides are equal. So if this side is, it's 7 meter, also this side is 7 meter. So in total we've got 14. In total we've got 14. In total we've got 14, because when you add these two sides, and this side is 6, and when you times 14 times 6, it will give you the area of the area of this triangle. So this is how you calculate the area of a triangle. And also we've got the perimeter. So in this instance, in the example that I've provided, how I managed to get the 14, it's more of using the perimeter formula. So when you have a rectangle like this one, these sides are equal, and when you want a perimeter you'll have to add these sides. So a perimeter will be 2 length plus 2 breadth, meaning these you need to add them, and then same applies to this. So for in order for me to get the 14, I added the 7 and the 3 because they are equal in length. So that's why I arrive into this answer. So I use the perimeter formula. The perimeter formula, you need to calculate the perimeter of a triangle, a square, or a parallelogram, the two length and the two breadth, and the answer is in millimeter, centimeter, meters, or kilometer based on what you were given the statement. So in this instance, let's say for argument's sake, we were given in kilometer, so our answer will be in kilometer. Let's say for instance, like here we've got, yeah, no, sorry, let's use something similar. Like here we've got the centimeters, né? And when we times 2 centimeters, because of using an area formula, when you times 2 centimeters, your answer will be in centimeter squared, because of uh, we are we are timesing the 2 centimeters. In instance, in this example, the answer, when we plus the two answers, let's say 14 plus 6, it will give you 20. The answer will be in 20 centimeter. Why not centimeter squared? Because of we are adding, we're not multiplying. So when we multiply, your answer will always be in centimeter squared. But if you add, the answer will be in centimeter. So those are the two differences that you need to know when you times and when you add. Let's move on. So we've got the circumference. So it's similar to a perimeter, but circumference is the word we use to describe the perimeter of a circular shape. So the good thing is that the circumference comes with a formula, and within that formula you just have to substitute what you have. So in most cases you will be given values. So this, in basic form, this is just a formula for circumference. So it's a 2 pi and a radius. So diameter or r is it's the radius. So you'll be given pi is constant, it doesn't change. You can utilize that or find that within your calculator. And also there is 2. Why did they divide by 2? The reason why they divided by 2, it is because the diameter, which is not the radius, the radius is half, the diameter is full. So in the radius, there is 2 opposite of it, like as you can see. So you'll divide it by 2. So if it was r, for instance, the distance, it's 1, it should be 1, so it will only be 5. So that is the difference. Let's say for instance you've got a circle and there's a radius from here, and it's 2 instead of 5, it's 2.5, and we using the same formula. This is equals to 2 pi radius it's 2, 3.14, 3.14, and the radius will be 2.5. It's not in diameter, and the answer will be 15. So 15.7. So because of it's a diameter, you'll have to convert that. You need to divide the 5 by a 2 because of diameter there is 2. So those are the difference that you need to adhere to. Those are the difference that you need to adhere to. So an area, it's more of calculating your length and breadth. We have done that. And also the area of a circle, to calculate this is the formula. Just you have to apply what you are given. It's much more easier. So the pi is constant, the r, it's this one is different. The I, it's not a circumference but it's an area. So let's check. Okay, so we've got a equals to pi r squared. It's constant, it's 3.14. You'll use the same 2.5. 2.5, we'll square it. So your answer, when you 3.14, 2.5 squared, that will give you the area, which is 19.62. I'm just playing around with figures so that you can understand the concept or grasp the concept. This topic is much more easier. It's simple. It's not complicated. It's simple. Just need you to apply the functionalities. So same thing with area. Just have to apply and substitute. Go through these functions and its formulas. So it's not hectic. It's not hectic. You just have to go through what you are given, and you won't have issues in terms of attempting your answer. So we are done with this learning unit number 3. So let's just go through the questions, your activities within your formative, not yeah formative assessment. So learning unit 3, session 1. What you need to do, you need to write down the measurement in millimeters, centimeters and meters of the following lines. So what you need to do, you just have to measure these lines, your A, B, C, D and E. You just have to measure these with a ruler. So they want it in millimeters, centimeters and meters. So there should be a ruler. You should use a ruler and a measuring tape in order for you to get these measurements. And also activity 2, you need to convert the following units from standard international to imperial. On your learner guide, I think on your learner guide it's page yep, it's page 82. There's a table that you'll find. Please go through that. It tells you same as a format that we used in terms of from your meter, converting it to your meter, you times it by this is the same process that they use. So to convert from inches to centimeters, you multiply by this. So the good thing that you are given the values, and there's an example. It's much more easier to convert uh, by following this instruction. So on your learner guide, you are required to convert these values for 34 centimeters to inches. Going to your table, 34 inches, uh, 34 inches. What we need to do from the table that we are given, from inches, to convert from inches to centimeters. The question is what we need to do. We need to convert from centimeters to inches. So we need to convert from centimeters to inches. We multiply, convert from multiply by 0.39 0.3937. So you have a 34 times 0.39 and what so forth, and you'll find your answers. You'll find your answer by multiplying that. So your answer will be in inches. That's how you should do. So you tackle that. It's easier to do the same thing, liters to gallons, same approach, doesn't change. You need to convert the following from 16 ounces. You use the same approach. Activity 3, identify the following triangles. We went through that. If you go through all the properties of the triangle, you would know which type. You just mentioning, you just identifying whether this is a right triangle or this is not a right triangle. It's a parallelogram, it's an equilateral. You just identifying them, and you need to calculate the unknown angles for the description that we were given. So on your learner guide, you were given on your learner guide you were given example in order for you to calculate. So how do you get your angle? So like, let's say for instance, we know that a straight line is from your, let's do this, from your Cartesian plane. This line is 180. So when you have an angle like this sort of angle, let's say you are given an angle to say, we know that from this example 1 and 2 is equal to 180, and when you seek an a when you we know that 1 and 2 is 180 because of the angle lies on the the x axis, so when you want an angle that you're given, like the one in your learner in your activity, to say calculate angle AB, what you need to do, because of, this is angle 180 and you were given angle 50, so we know that angle 80 minus 50, it will give you angle 130. So we know that AC lies within the 180 x-axis, and in order for us to get maybe angle A, the unknown angle, we have to minus, which is 130. 180 minus 50, it will give you 130. So this is the unknown angle that they refer to. So you'll use the same approach to all angles. For this angle, in order for you have to use the same approach. So go through the properties and understand the properties, and you calculate according to based on what they required. Section 3, a field is 30-meter long and 50-meter wide. Calculate the perimeter and the area of a field. You know that the perimeter, what you need to do, you need to add all the sides, and the area of the field, you need to times your length and breadth. So in the activity 6, in the diagram below, calculate the length of BC, hence the area of a quadrilateral ABCD, the length of BC. So you need to calculate the length of BC. You know how to calculate the length. This is how you should go about an activity 7. Draw the two-dimensional shapes and transform them into three-dimensional shapes by adding a height or a depth of 3 centimeters. So by drawing that, it's more of something like this. So this is a 3D, and you need to a square with dimension of 2 millimeters. You'll just name that 2 millimeters. A rectangle with a square with dimension of 2 millimeters, a rectangle with dimension of 3 millimeters by 2 millimeters, a right angle triangle with an adjacent side of 3 centimeters and an opposite side of 2 centimeters, a circle with a diameter of 4, and a semicircle of a radius of 1 meters. These are easier. Easy. Your right triangle with the with an adjacent side of 3 centimeter and a circle of a diameter and a circle of a radius. And the good thing is that they don't ask you to calculate, but we managed to get through that. So they ask you a circle, the diameter and a radius, and they ask you about drawing up a right triangle and a square with the dimension of 2 millimeter. So that's it with activity 7, and I'll continue with learning unit 4 and 5 in the next video that I will provide. Thank you.